So we're here today to do what?
See which cup's better out of the Yeti, RTIC, and Ozark trail.
At holding what?
Ice.
At holding ice. So we're going to look at this experiment using the scientific method. Number one is identify the problem. What is the problem?
Which cup has the most ice?
All right. They all claim to be as good as the other one or better. Number two, research. How did we conduct research?
We watch YouTube videos.
Watching YouTube videos. And what did you find in your research?
There's always bias.
What does bias mean?
There's an error.
There are some errors in almost every video that we've seen. So let's do our hypothesis. If
We compare the Arctic, Ozark, and Yeti.
So if we compare the Arctic, the Ozark Trail, and the Yeti cups, then, now wait, how many of you think the Yeti will be better? Several. Arctic, the majority, and then Ozark Trail. No one. Y'all are hating on Walmart. Okay.
Yes.
So our hypothesis, since most people said Arctic, is if we compare the Arctic,
Ozark, Yeti cups.
then the Arctic
will hold the ice longest.
the Arctic will hold the ice the longest because it's constructed very similar to the Yeti. Okay, now let's start. Number 4, the experiment.
Dun, dun, dun.
Y'all are hilarious. Okay, what is the independent variable on our experiment?
The cups.
What do you mean the cups?
The Arctic,
Arctic, the Yeti, and
Ozark,
the Ozark
Yeti.
trail.
Okay, that's the thing we are changing on purpose, right?
Yes, sir.
Okay. What's the dependent variable? First, what does dependent variable mean?
The thing
The
we're
thing we
gonna
measure at the end.
Okay, it's going to be what we're measuring at the end. What are we measuring at the end?
The water from the melted ice. The ice.
The amount of ice
Okay,
left.
let's back up just a little bit. We're measuring,
How much ice is left?
all right, how much ice is left in each cup. Can we measure that really well, or is there a smarter way of measuring the ice?
You measure the water that melted off of the ice.
Right, you measure the water that is produced by the melting of the ice, and then you'll find out which one kept ice the longest. And then the last variables that we need to control are,
The amount of ice that we put in the cup.
so the ice has to be the same, which that is one of the major problems we see in the YouTube videos, is you don't really know if they put the same amount of ice, right?
They estimated in it.
Right, and we're not going to estimate, we're going to get it just right. So, what's something else we have to control? The what?
The temperature at which we keep it.
Okay, the temperature we keep it. Tell me a little bit more about that.
If we have them all at different temperatures, then it might melt faster.
Okay, so they all need to stay with the same temperatures. Anything else?
Location.
Location, same cup,
Temperature.
anything else?
The size?
What do you mean the size?
Like the size of the cups.
How many
Okay,
ounces the
we have
cups are?
3 30-ounce tumblers. So in other words,
Everything has to be the same except the cups.
everything has to be the same. All right, good job. Here we go. Okay, what is the major thing that we're going to control first?
The
ice.
in the cup.
All right, the amount of ice going in the cup, right? Now, are we going to measure the ice and get it right, or is there a better way of doing this?
Measure the water.
All right, we're going to measure the water that's going to make the ice. So we're going to make, I'm looking at this in a graduated cylinder, about how much water is in there right now?
100 milliliters.
100 milliliters. And if we need to adjust that a little bit, what are you using to adjust it?
The pipette.
Okay, so I can add or subtract little drops. Now, whenever I'm measuring a meniscus, whenever I'm measuring the water, what do I look for?
The meniscus.
The meniscus, okay. And so I'm measuring the top, bottom, or what?
The bottom of the curve.
The bottom of the meniscus. Okay, good deal. All right, so let's make a block of ice. Take the cup out. Are we sure we have 100 milliliters of water?
Yes, sir.
Okay, pour it in. Yeah, everybody's whispering, don't spill it. Make sure you get it all, a little bit, tap it a little bit. There you go. All right, and through the magic of video, Now we have ice. Now this water has been sitting overnight in the freezer. How much is in each cup?
100 milliliters.
100 what? Milliliters. 100 milliliters, and we're going to put 2 blocks of ice in each one of our cups. So, here we go. Pop off the cups. Quickly, 2 in each cup. Lids back on the cup. And we will revisit all of this in a little while. Now, where do we need to put the cups? Wherever we put them, they have to be
Same location.
same location. Would it be safe to put it up here?
Yes.
Just leave it up here?
Possibly.
Yeah, let's leave it right here. Good deal. Separate the cups out so they don't influence each other. Let's put them in a straight line. Good deal. Okay, we're here 24 hours later, and we're going to check some of our results. So first, let's take a look inside. What do you see in the Arctic?
Water and ice.
Okay, chunk of ice. What do you see in the Ozark Trail?
More ice.
Water and ice. And the Yeti?
Ice and
All right, so how are we going to measure the ice?
By the amount of water that
Funnel the
melted.
water out with the funnel
All right.
into our.
Let's put the funnel in the graduated cylinder. Okay, so this is what we found. The Yeti produced how much water?
150 milliliters.
The Arctic?
158.
And the Ozark Trail?
141.
What's your conclusion here?
Ozark Trail is better.
The Ozark Trail held the ice the best, followed by the Yeti, and the worst one was the...
Go Wally World.
Let's do it again. All right, we're doing experiment number 2 with our Yeti, Arctic, and Ozark Trail. The first experiment with a block of ice found that the Ozark Trail actually held the ice the longest. So we're going to do it again with chunks of ice, like you would normally put in there. See? Yeah. All right, so we have the Yeti, the Arctic, and the Ozark Trail. We found that the beaker weighed how much?
The baker weighed 49.5 grams.
Okay, how much is that ice that you have right there?
409.
Okay, so
0.5
400.
grams.
Okay, how much?
409.5 grams.
Okay, so how do we find the actual weight of this ice? Subtract, and we're going to find out how much we're going to put in the Arctic. Okay, now we're going to put in the same amount of ice into the Arctic. We're almost there. We need a little piece of ice to zero it out, to zero out the weight. All right, we have too much ice now. We're going to have to take a little bit out.
Can I eat a piece of this?
Sure.
No. Okay. Another little piece like that. And
I
that
can
should be
bust some
good.
up with my fist.
There you go. Alrighty, we are.
It's good.
Hang on. Okay, we're there. Okay, let's pour it into the Ozark Trail. Okay, good deal. Cap it up. Let's do the same thing for the Yeti. Okay.
We need an ample amount of more ice.
Oh my god.
Whoop, it went up. Okay, let's get this fixed.
It won't come out.
Okay, hang on.
Little
Little
piece.
pieces. Wait,
Too much. I got this
wait,
here.
wait.
Oh my god.
How's it looking, Chase?
Hey, some took out.
A little too much.
Take that little piece out.
Where'd you put it?
I don't know.
That is.
that ice right in here.
Me, that's right on it.
A little bit below.
Just a tiny flake of
Here,
ice.
I got it.
I busted some up first.
Oh my god.
How we looking, Chase?
It's not even moving.
Just a little bit more. That's about it.
Okay, pour it in the Yeti. And we will revisit this in 24 hours.
I don't.
Yeah.
All right, we're here for trial 2. What are we comparing, y'all?
That cups.
You have to be really loud.
The cups.
The cups. What kind of cups?
Yeti,
Yeti, Arctic,
Ozark,
Ozark.
and
Okay. The Ozark, the Arctic,
and the Yeti.
and the Yeti. Now, since this is trial 2, we've already have some results, but we'll get to those in a little bit, okay? What's our independent variable?
the
cups.
3 cups.
What does that mean?
The
What's
one we
in-
changed on purpose.
The independent variable is what we change on purpose. And what is our independent variable?
The different brands.
The different brands of cups. What is the dependent
The
variable?
one we measure.
What we measure at the end, which is going to
The
be
water.
the one that has the most ice at the end. Now, are we going to measure the ice directly?
No, we're measuring how much water was melted from it.
All right, so the more water,
That came off the ice.
is that a good thing or a bad thing?
Bad.
All right, so the more water, the less ice is left in. Does that make sense?
Yeah.
Okay, we all know this, right? Okay. Sir, you want to go ahead and pour out the Ozark Trail. And this is exactly 24 hours later.
That's all?
Okay.
Still going. You still got some in there.
We got to get it right. A lot of people depended on this.
That's almost 250 milliliters.
Okay, let's take a look at how many milliliters.
Wait.
That's a lot.
Take out the
Yeah, take the funnel out. So, how many milliliters do we have here?
237.
236, 237, probably 237. Okay. We can't really see the meniscus very well on this one because this is such a wide graduated cylinder. What is a meniscus?
The curve of
The curve in the liquid, okay, and we always measure from
the bottom of
the bottom. All right, so the Ozark Trail, you have that one down to how much?
237.
237 milliliters of water. Okay? Now we can leave it right there.
We're gonna measure them together.
Let's take a look at the Arctic.
Oh, he's done. He got him. Ozark Trail beat.
Yeah, it's past 250. Cubby, you're past 250 now.
Actually, you gotta take the funnel out.
Take the funnel out.
Oh my god.
looks the same.
It's like
All right. We are above our graduates, so we are above 250. Can you estimate about what that is? So, the Ozark Trail held ice better than the Arctic.
Yes, sir.
Okay, $10 held better than, how much are these now, 20 or 25?
20.
Around $20, okay.
So I guess 250.
Let's take a look at the Yeti,
Bam.
Oh, that hurt my ears.
the bad boy of all the cups, right?
Supposedly.
That cost like $50. 250 exact.
Boom, 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 boom. Another one going down.
Another one went down. Okay,
Uh-oh.
let's take a look at it.
Oh, beat it barely.
Right at 250 milliliters.
250?
250. You have that down? All right. So today's results show which one is the best cup. Which one's the second best?
Yeti.
Which one's the third best?
Arctic.
Yesterday's trials,
It was the same.
It was the same.
same exact order. What's the difference between how we did the ice today? Today was crushed ice, and we put the exact same amount of ice in both. How did we do the ice last time?
We measured it in a beaker.
In two big
that's the-
cubes, and we created those cubes, so we knew that they were exactly the same. So twice in a row, Ozark Trails, best cup out there, right? Now we have a couple of requests on Facebook to do the same experiment in a hot car. A couple other things. So you want to accept the challenge?
Yes.
All right. So we challenge any Vernon Parish School or any junior high school or any high school, college, or whoever, or anybody at home to check our results and do, what is number 8?
Peer review.
Peer review. We're looking for someone to peer review our experiment.
Challenge
All right.
LSU.
Do what?
Challenge.
Okay, LSU,
LSU.
try it. You know, Alabama, I know y'all wouldn't understand. All right, thank you guys.
Okay.
What do y'all think about these results?
Well, my life is ruined. I've been living a lie.
Anybody surprised by these results?
I don't know the brands.
I don't think anyone chose Ozark Trail as the winner.
I did that in my book, but then I changed it.
You changed it.
Because I like the Arctic name.
I chose Arctic. It looks cool. Yeah.
I chose Arctic because I had an Arctic.
I really don't.
You chose Arctic for the experiment because you had an Arctic.
Yes, all the way.
Give me a good Arctic.
How many of y'all chose Yeti because it's the most expensive? Okay, I'm putting my hand up too. Okay.